Hello students, today we're going to discuss about ICSE Class 7 Chapter 4 Structure of an Atom. This video is about radicals, atomicity and valency. In previous video, we discussed about structure of an atom, Thomson model of an atom, Rutherford's model of an atom and Niels Bohr model of an atom. Molecules. The atoms of many elements cannot exist independently. If they combine with other atoms of the same element or other elements, they exist as a molecule. So, atoms may combine with another atom of the same element or they combine with other atoms of different elements to form molecule. See, molecules of hydrogen. This is made up of same type of atoms. But molecule of water, it is made up of different types of atoms, hydrogen and oxygen. And this is also example for molecule having same type of atoms. And this is HCl, hydrogen chloride, as different types of atom, hydrogen and Cl. So molecule may have a same type of atoms or different types of atoms. Next, we're going to discuss about atomicity. Very interesting topic. The numbers of atoms present in a molecule of an element or compound is called as its atomicity. Monoatomic, so based on the atoms which is present in the molecule, it's classified into monoatomic, diatomic or triatomic, polyatomic molecules. The number of atoms present in a molecule of an atom or compound is called its atomicity. On the basis of the atomicity, molecules are classified as monoatomic, diatomic, triatomic or polyatomic. Molecules that contain only one atom are called monoatomic molecules and their atomicity is 1. Example, noble gases, helium, neon, argon, krypton, xenon, radon are monoatomic molecules. Molecules that contain two atoms of the same element are called diatomic molecules. Example, hydrogen, nitrogen, oxygen, etc. have two atoms in their respective molecules. The molecules that contain three atoms of the same element are called triatomic molecule. Its atomicity is 3. Example, ozone. The formula of ozone is O3, has 3 atoms of oxygen in its molecule and is an example of triatomic molecule. The molecules that contain more than 3 atoms of same element are called polyatomic molecules. For example, phosphorus contains 4 atoms of phosphorus in its molecule. So its atomicity is 4. Sulfur contains 8 atoms of sulfur in its molecule. So its atomicity is 8. Types of molecules: monoatomic, diatomic, polyatomic, more than 2. So monoatomic has only 1 atom, diatomic has 2 and polyatomic has more than 2. These are examples for diatomic molecules: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Next, we discuss about radicals. Radicals is a single atom or group of atom that carries a charge and function as a single unit. So, radicals or maybe a single atom or group of atom which carries a charge, maybe a positive or negative charge, and behaves as a single entity. They are also known as polyatomic ions. They are also known as polyatomic ions. A radical may be single atom or group of atom. Example, you take hydroxide ion. This is the formula of hydroxide, OH minus. It's a radical, consists of 1 oxygen and 1 hydrogen and carries 1 unit of negative charge. So, group of atoms carries a negative charge and acts as a single unit. So this is known as radical. Next, chloride ion is a radical that contains a single chlorine atom and carries 1 unit of negative charge. So it is represented as Cl minus. So Cl minus is the radical, and this is not necessary the charge should be as negative, it might positive also. Magnesium ion Mg2 plus, aluminium NH4 plus. So this acts as a group of atom acts as a single entity, carries a positive charge. Here magnesium ion, single atom, that is Mg, carries a positive charge. So this is what it's called as radical. Carbonate CO3 2 minus, nitrate NO3 minus, oxide O2 minus. So radical is a single atom or group of atom that carries a charge and function as a single unit. Next, very important topic, valency. So before we discuss the definition of valency, you have to know what is actually outermost shell and valence shell and about valence electrons. So as we have discussed in the previous video, electrons revolves around the nucleus in different energy levels, shells or orbits, called shells or orbits. So 2 electrons can accommodate in the first shell, 8 electrons can accommodate in the second shell, 18 electrons can accommodate in the third shell, 32 electrons can accommodate in the fourth shell, and they named as K, L, M, N, or instead of using these letters you can also use like numbers, first shell, second shell, third shell or fourth shells. You take hydrogen, atomic number of hydrogen is 1, hydrogen has 1 electrons. That shell which is far away from the nucleus is called outermost shell. Even though hydrogen has only 1 shell, this is the far away from the nucleus. So this is called as outermost shell or valence shell. The electrons which is present in the outermost shell is called valence electron. So hydrogen has 1 valence electron. You take lithium. Atomic number of lithium is 3. Lithium has 3 electrons. As the first shell can accommodate only 2 electrons occupy the first shell and third electron is moved on to second shell. So this is the outermost shell for lithium and the outermost electron is 1. Next to sodium. Atomic number of sodium is 11. So sodium has 11 electron. So 2, 8, 1. The second shell can accommodate 8. So 2, 8 and the remaining 1 electrons move to the third shell. So this is the outer shell for sodium. So the outermost electron is 1. The valence electron of sodium is 1. We have discussed 2 electrons can accommodate first shell, 8 electrons can accommodate second shell, 18 electrons can accommodate third shell. But if it has the 8 electrons in the outermost shell, the atom will be more stable. So all atoms tend to achieve stable electronic configuration by losing, gaining or sharing of electrons. Only valence electrons participate in this lose, gaining or sharing of electron. Example, you take numbers of electrons in the outermost shell. If it is 1, it has more tendency to lose 1 electron. So the tendency of an element to lose, gain, share electrons in order to get stable electronic configuration is called as valency. So if it has 1 electrons, it has more tendency to lose 1 electron. So the valency will be 1. You take in the case of sodium. So the electronic configuration is 2, 8, 1. So it has 1 electron in the outermost shell. So it has to lose that 1 electrons in order to achieve stable electronic configuration. In this case, sodium has more tendency to lose that electron, lose 1 electron. So then it achieves the valency 1. If it is 2 electrons in the outermost shell, valency will be 2. If it's 3, valency will be 3. Has more tendency to lose if it has 1, 2, 3 electrons. If it's 4, this is based on the situations. It might lose the electrons or gain 4 electrons. But whatever, the valency will be 4. If it's 5, 6, 7, instead of losing these electrons, atoms gain electrons to achieve stable electronic configuration. If it's 5, it receives 3 electrons. If it's 6, gain 2 electrons. If it's 7, gain 1 electrons. If it is 8, there is no need to gain, lose, share electrons. Why? It's already has stable electronic configuration, that is what 8 electrons in the outermost shell. So valency will be 0. So then what is actually valency? The valency of an atom or valency of an element is a measure of its combining power with other elements. There are 3 different definitions for valency. So valency is measured in terms of hydrogen atoms or oxygen atoms. It is the numbers of hydrogen atoms or double the numbers of oxygen atoms that can combine with it. Example, you take hydrogen, valency of hydrogen is 1. So valency of an element is a measure of its combining power. It means hydrogen valency is 1 so that it can make a bond, one bond with other element. So the valency of an element is a measure of its combining power with other elements. Or it is the number of hydrogen atom or double the numbers of oxygen atom that can combine with it. Modern definition of valency: the numbers of electrons that an atom can lose, gain, share electrons during the chemical reaction is called valency. Hydrogen, outermost electron of hydrogen is 1, valency of hydrogen is plus 1. Bromine, outermost electron is 7, valency is minus 1. So the combining capacity of bromine is 1, combining capacity of hydrogen 1, so that hydrogen make one bond with bromine, bromine make one bond with hydrogen, so that you are getting HBr. You take HNO3, hydrogen, valency of hydrogen is 1, NO3, this radical valency is minus 1. So that both the radicals valency is 1 so that it can make a bond. So HNO3. Next, periodic table. So periodic table is a tabular arrangement of all the 118 elements known so far. It has 18 vertical columns called groups and 7 horizontal rows called periods. Elements are arranged in their increasing order of atomic number. So it has 18 groups, 7 periods. It has 18 groups and 7 periods. Vertical columns are called groups. Horizontal rows are called periods. And each box in the periodic table, each box gives the details about atomic number, symbol of the element, name of the element, mass, and valency. Aluminium, symbol, name, atomic number, mass number, and this is the valency of the aluminium. Germanium, you will find 180 elements, name, symbol, mass number, atomic number, and the valency in the periodic table. The elements present in the group, same group, exhibit similar properties. Example, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium present in the same group, first group elements, they exhibit similar properties. Significance of periodic table. So it gives the detail about the symbol of an element, valency of an element, the mass number, that is the total number of protons and neutrons present in an atom of the element. So it gives the symbol, valency, mass number. Mass number is the total number of protons and neutrons. So I'll get idea about the numbers of neutrons present in the element. Atomic number of an element is represented as Z. Always atomic number represent the letter Z, mass number by A, then element symbol X. Example, you take hydrogen, this is a symbol of hydrogen, atomic number 1, this is the name of the hydrogen, this is the atomic weight. Thank you, students. Subscribe my channel for more videos.